In section 3.1, we're talking about functions and function notation. So up until now, we've typically been working with equations such as y equals something. And now we're going to be talking about functions. So it's a function of x that equals something. And this something is probably going to have some x's in it. So let's just get this as an example. So when we're talking about whether or not something is a function, we can look at the input values and see if they map to just one output value. So in this case, each of these inputs maps to one single output. So this is a function. This next one also maps to just one single output for each input. So this is also a function. But then when you get to this last one, you've got P that maps to one single output, but then Q maps to two different outputs. This one is not a function because you need to have something where you know that when you put a value into the function, you're going to only get one result. Can you imagine if you selected 503 out of the vending machine, and one time it gave you a Dr. Pepper and the next time it gave you a Coke? That would not be very cool. So that's a good example of something that would not be a function. So in this next question, it's asking whether or not the item is a function of the price. So item plain donut equals the price of $1.49. So that only has one price. The item of jelly donut has only one price, and the item of a chocolate donut only has one price. So yes, that's a function. And then the next question was asking whether or not the price was a function of the item. In this case, it's not, because just like the vending machine option, here, if you selected something that was $1.99, this would map to two different things. So this one would not be a function. And visually, here's an example of this. So if we have our f of x equals 31, in this case, January is the input. The rule, it looks like, is saying how many days are in that month. So your output for January would be 31. And then here's an example where you can map. So your function value, h of p, is 3 when you plug in a negative 3. So if you go to x and go down to the negative 3, your value is going to be positive 3. In this next example, they want you to find the value for the function. So in this case, they're asking you to evaluate f of 2. So we're going to go find f of 2, which is here, and go up. It's going to be an f of x equals 1. In this case, they want you to evaluate when f of x equals 4. So this is different than f of 4 equals what? I hope you can see that. Now it's asking what value of x will give you 4. This one is asking you what's the value of the function at x equals 4. So two very different questions, but they look very similar. So let's go back to this one. It's asking us what values of x make the function equal 4. So we're going to go to the y value of 4, and here they've drawn a straight line across, and then we're going to find out what these 2 points are. So drop down to the x value. This is negative 1. So f of negative 1 equals 4. And this next one, drop down, and it's 3. And f of 3 equals equals 4. Now we move on to visually being able to tell whether or not something is a function. And there's something called the horizontal line test and the vertical line test first. So the vertical line test, imagine a line running across your graph vertically. So you can run this line all the way across your graph, and if it only hits one time, it's a function. So now let's look at these ones. So again, they've got your vertical line, and as you run it across the graph, it's only hitting once. This one hits twice. So this one is not a function. And this one also hits twice, so it's not a function. Let's look at these ones. So again, you can, if you have a pen or a pencil, you can kind of visually run that along your line. That works well. Otherwise, if you needed to draw a line, that works too. And you can see that as we move this vertical line across the graph, we're only going to be hitting in one place at any one time. So this one is a function. Here, let's do this one. And again, as you run this vertical line across the graph, it's only going to hit in one place the whole time. And now, when you get to this circle, we're hitting twice. I hope you see that. So this one is not a function, but these two are. And now there's something else known as a function being one-to-one. So similar to our donut example, if you, let's say that this last donut was 179. Now this is a one-to-one function, because if I told you I ordered the plain donut, you would know how much I paid for it. And if I told you I paid $1.99, you would know what donut I ordered. But if we go back to the original value of $1.99, if I told you I paid $1.99 for my donut, you wouldn't know if I ordered the jelly donut or if I ordered the chocolate donut. So this one was not, it's not one-to-one. But if we change that to 179, then it would be one-to-one, because if I told you I paid $1.79, you would know I ordered the chocolate donut. So this is where the horizontal test comes in. So if you draw a horizontal line across your function and it hits twice, then it is not one-to-one. It's still it could still be a function, could be still a function, but that means it's not one-to-one. So here's an example where if we did the horizontal line test, it is not a one-to-one function. But it is a function. So if you do the vertical test, your vertical line test, and run it across your graph, it's only going to hit at one point along the way. And here's another example where it is a function, because you can do the vertical line test and it passes that, but it's not one-to-one, because as soon as you take your horizontal line, you start hitting in at least 2 places, and even here you're hitting in 3 places. So this is definitely not one-to-one. And that's it for this section. So I'll make another video for section 3.2.